Amplifier, an undeniable climate emergency podcast.
Today we have a great conversation with Austin Bowden-Kerby, who specializes in working with Pacific Island communities and governments to prevent the collapse of coral reefs in the face of climate change and associated mass coral death due to bleaching. He incorporates the gardening of bleaching-resistant corals into community-managed reefs and into coral gardening programs at resorts. Austin goes deep into the processes he uses to help prevent and restore coral reefs and how these wonderful marvels of nature are not just important to the seas, but for all life on Earth.
Well, why don't we start with you just introducing yourself?
Okay, I'm Austin. I'm William Austin Bowden. I was born in 1954 in Lexington, Kentucky. My father was a graduate student of economics, and I was a little baby who grew up eating red Kentucky dirt. But both my parents are from Wilmington, North Carolina. Both of them were from fishing families, and my mother's family was it was called Fales and Fales, and they had been McPhail before they came over from Northern Ireland, and they had a fish market in Wilmington, North Carolina, and so both sides of the family were sounders. They lived in Riceville Sound and Masonboro Sound, and both of my grandmothers were alive when I grew up, and we used to go visit them and stay for the summer on the Sound with the ocean, crabbing and fishing and in boats and that sort of thing. It was really a good life. And it's before all this overdevelopment started happening and this cancerous materialism caught on so badly, which is now eating at the vitals of the planet. And so climate change was not something we talked about. Yeah. We actually lived in Norfolk, Virginia for 6 years. We lived right on the water. And where I used to play in our yard, our backyard had a raised part, and there's another part that was sandy and right on the beach. It had a little beach there. Oh. It's gone now. So I went back after many years, and I saw that sea level rise is very real. So what used to be a beautiful sandy place for playing is now a salt marsh full of mud. And the sea has come up. And, up in my lifetime, the sea has come up at least, and in Norfolk, because of changing currents, it's actually gone higher than in other parts of the world. It's higher than the average. So we have, with climate change, we're facing a very, very big challenge to civilization. And most people don't recognize it yet. There's a bunch of talk and there's very little action. And people say, oh, I've got an electric car, I'm going to help. Well, electric cars are using the same same energy. So it doesn't really help that much, if at all. If you have solar powered electric car, maybe that's good. But it's not part of a big comprehensive solution. And the big solution has to involve the whole planet. And here in the South Pacific, we have, it's just basically the water hemisphere. And I was fortunate because when I was 11 years old, my father, the economist, moved us all to Saipan in the Mariana Islands. And I was in an island school with island people from the time I was 11 till I was 13. And I enjoyed it thoroughly. I liked the mentality of the islanders, fighting each other and playing. And I basically got attached to islands. I swam on a coral reef when I was very young. And I was just really fascinated. And I thought it was like going to heaven, It was all quiet there. Nobody could criticize you or fight you or anything. It was just really beautiful, peaceful. And later on, and I went back to the States and I kind of felt lost. I just kind of felt like I wasn't my place because I had experienced this amazing paradise. And so I finished high school in upstate New York in 1972, and I moved down to North Carolina to try to get my residency so I could go to school there, and I did. And in 1974, I don't know, 1973. Yeah, 1973, I entered the University of North Carolina at Wilmington. I was living with my grandmother, and she was all alone. Nobody would stay with her. So I moved in with my grandmother, helped her with the chickens, made a giant garden. She taught me all about farming. And I entered the biology program at University of North Carolina at Wilmington. And then I got a phone call in the summer I got a phone call in the spring of 75. My father said, I'm living in Fiji. I have a job as an economist in Fiji, and the United Nations is going to pay your way because you're still 21. So I just, for the skin of my teeth, me and my younger brother and younger sister all got to go out to Fiji. And that was, in 75. And we traveled all over Fiji with my father. And I also I made friends and went away from where he was, and I went and fishing with the local guys, spearfishing. I didn't know how to spearfish, but I swam with them and saw the most incredible coral reefs in the world. And I saw the crown of thorns starfish just absolutely destroying the reef. And I decided I was going to go home, change my major to marine biology, and I was going to come and live in Fiji when I finished. So I went back and I finished in 77. I came back out and couldn't find a job, but I was volunteering and doing work in the communities, ended up in Micronesia. And then I decided I needed to get married. So my girlfriend in America, we met in North Carolina in 79, got married, and we moved to Guam, where I entered the master's program. So anyway, this is too much detail, but
fascinating. I love it.
Yeah, but if any young people are out there, the thing is, this is us back in 79 on the wall. We've been married for 43 years. One of the primary things that hinders people from being productive in this world is they mess up their life. Okay. So if you're young and listening to this, the most important thing is that you find your life partner, you find somebody who you love, that you're looking in the same direction. Basically, you don't have to be doing the same things, but my wife is not into marine biology, but she's into sewing and completely other things, but she loves living the local life in the islands. We had 4 children. We lived without electricity, and she loved it. Washing clothes by hand in the stream with the ladies, with the little children all swimming in the water. And it was a idyllic life, and she absolutely loved it. Never mind the children had lice or intestinal worms, all the kids did. She was a nurse, a registered nurse, and she knew about stuff, and so she kept us all healthy and alive. I didn't die, even though I got a lot of sicknesses. I had hepatitis, I had leptospirosis, I had malaria from when I went to the Solomons to visit and do work there. I got dengue fever, I got typhoid fever, I got a lot of things, and Kim kept me alive. So walking at night to get some IV fluid and across the hills, in Chuk. So my concern in Chuk was the dynamite fishing. And seriously, the Japanese fleet was sunk on the bottom of the lagoon. It was not sunk too deeply, so it had amazing corals on it. And the U.S. government trained 50 people in scuba diving to start a tourism industry of scuba diving tourism. And it's quite famous, Truck Lagoon, right? But the problem is this. There's only a small plane, and very few tourists actually go to Chuk. It's far away. And so you had trained 50 people, and there were no jobs. So what the people had been given their gear. And so what they did is they went on those wrecks. They took the bombs and the mortar shells and so forth out of those wrecks. And you can take a hacksaw and open them up under the water, right? Under the water, they would open them up, take out the gunpowder, which is not powder at all. It's these little centimeter square things of kind of a plastic. It's gunpowder is non-wettable. It's in a plastic form, and they would take this out under the water. It wouldn't explode because, the friction under the water. And they would open this up and make dynamite. And that became the primary means of fishing in Truck Lagoon. And it was obliterating the nearshore reefs. And people had no right to go and fish on other people's reefs, but they had faster boats because they had money. They had guns. They had gotten guns, so that nobody could challenge them. And they went around, and this was the primary. You'd go into the town, Moen or Wara, and the only fish you could find were dynamite fish. And so we ate dynamite fish multiple times, and you clean the fish, you'd see the broken spinal cords, a little bit of bleeding there, the ruptured swim bladders, all these signs. But I saw the impact on the Chukis people because the children started going blind. Okay. People traditionally they don't have money, and they eat what they catch and what they grow. And when you remove the traditional food source, the reef fish, because of this dynamite fishing that was going on, you destroy the fish habitat. The corals are the fish houses. So when they're dead and broken, the fish don't have anywhere to live. And so you don't have many fish. So fish were removed from their plate, and the children, the traditional vegetable of chook, because they don't grow vegetables, because the land crabs will eat them up. It's all shady because it's tree crops, it's breadfruit and coconut, and it's very rocky. So the traditional vegetable are fish eyes and fish livers from the reef fish. So they get their vitamin A and all their vitamins from eating the entire fish. And that's mostly in the fish head. So a parrotfish soup, the head would dissolve and go into that soup, and the bones would fall out, and all the vitamin A, amazing amount of vitamin A in a fish head around the eyes. So people had all the nutrients they needed growing up, eating breadfruit and fish, or taro and fish, and that fish was gone. So we had like 12 cases of blindness in children that year, or a couple of years when I went back, and it was pretty serious. So we tried bringing in these tree spinaches, these Polynesian bele, it's called, hibiscus. It's in the hibiscus family. We brought them in from Fiji. It worked in Pohnpei, where there were some Tongans and so forth who knew about it, and some of the Tongans we found in Fiji were really happy to have it, and they were trying to teach the local people. But the main thing is, and it did work some. The main thing is, how do you get the corals back when they're obliterated? So I started working on coral restoration, in addition to the work with the communities. And I looked at the reefs, and I looked at the big bomb craters from the war, and the Japanese, 10,000 people were stranded there, at least 10,000, because their fleet had sunk and they couldn't go back to Japan, and they were starving, and they were using hand grenades and mortars and so forth to fish. They're the ones who trained the Chukis that you could use explosives for catching fish. So, and it kept them from dying, at least some of them. And so there were big craters on the island of Toll where we were living. I was teaching at a school there. And these craters had been from the war, and there were no corals growing. But then along the edge, I saw these corals, and then you'd see where branches would break, fall into the zone, and start growing. So you'd see a purple coral here, and you'd see, hey, there's purple colonies, 1, 2, 3, 4, going into this rubble dead zone. And you say, it looks like the branches are breaking and recolonizing. So I broke coral branches and threw them down, and I got instant coral reef. Okay. And what was happening is that the broken branches would attract coral larvae, could settle there, but then it would turn over and kill it. So these were killing fields for coral larvae. The coral larvae were coming in, but they were these unstable dead branches were turning. So you could break a piece of that dead coral, and you look inside and you'd see just all kinds of baby corals along the edge that had come in and died. So I said, oh my God, look at this. So we have to restore this by breaking branches and throwing them. So that got me really interested. And then I finished I was still working on my master's degree at University of Guam. So I went back to Guam, finished my master's degree, nearly starved to death with the 3 children we had then. Seriously, it was bad.
The plight of graduate students everywhere.
Oh, it was really bad. So I started doing coral work there, restoration work, some experiments. I got a small grant, and then we were there for 8 years. And the coral restoration work I was doing around a little tourist island. So I got the grant to pay that we could go. I could go with the whole family there, and we could spend weekends there, and I could do coral work while the kids were all playing, and it was great. Anyway, so after 8 years, the kids were getting big, and I knew they needed a little bit of better education and to get out of there. So people were saying, yeah, you need to get your PhD, Austin. So I went, looked around. I got accepted to the University of Hawaii. I went there for a summer program, and I said, nope, I'm not going to be in Hawaii. There are no staghorn corals. That's the corals that most of the South Pacific rely on these corals that the fish can live in, the branched corals. Yep. And Hawaii doesn't have many branched corals, and it was too atypical. And I said, no, whatever I study in Hawaii will not be that appropriate for the rest of the world. So I want to go where there's staghorns. I end up finding that the University of Puerto Rico, Puerto Rico is a U.S. territory. There was a school that the curriculum was in English, and my professors were Americans, Japanese, Hawaiians, and there's some very good Puerto Ricans and very good Colombians and Spanish. It's a very good school, and at University of Puerto Rico. And I ended up going there. I got a little bit of an internship. Puerto Rico is wonderful because I had been playing with corals for those years in Pohnpei and Chuuk to start with, and from back in the late 70s. And here it was, 1993, we moved to Puerto Rico. And no one had done any coral restoration work in the Caribbean. And here it was, the acropa corals, the branched elkhorn and staghorn corals were collapsing. And that was well known, but nobody had started planting them. So I arrived in a situation where the first collapse of an ecosystem was happening. Okay, and it was disease related, which is maybe climate related because the disease thrives during the summertime, and as the summers were getting hotter, the disease was getting worse. So it probably related to climate change. And also hurricanes, the impact of hurricanes smashing those corals. But anyway, the corals were quite rare when I got there. They were still abundant enough because it was before the mass bleaching started hitting. And then after I was there, and I finished my degree in 2001, and then the 2005, the bleaching really hit. And most of the corals I worked with died. Okay, I mean, you can restore a reef, but if it's not resilient, and then it can die. So the corals had gone down to a certain point. I said, okay, now we have enough genotypic diversity to keep those species alive. And then the mass bleaching started and eliminated a lot of those. So a lot of people are working on coral restoration now in the Caribbean. Probably over 100 people are doing it full time. I don't even know. But I was the first one, and I developed a lot of methods that are still being used. So I, in 1998, Cyclone George hit. This big hurricane hit. It was crazy strong, and it destroyed pretty much the facility that I was working at. There was no power. We had no power for 29 days at our house, and the marine facility was really broken up. And I had a grant from the Sea Grant program, and it included 2 trips. I had done 2 trips to Solomons and Fiji already, and I said, well, could I take my family and get out of Puerto Rico because we're recovering and I can't do any work at the lab. I just have to work on my thesis. I have 1 year of funding. Could I take my family and go to Fiji? When I got to Fiji, the corals were in pretty good shape. There had never been a mass bleaching in Fiji ever. That was in 1999. And then in the year 2000, a mass bleaching hit and killed most of the corals in all of the southern part of Fiji. So it wasn't my fault. But I arrive and here comes this horrible event. And then after I was gone from Puerto Rico in 2005, most of the corals I had been planting ended up dying in a bleaching there. I haven't been back to sea, so I need to get back to Puerto Rico. But anyway, so in 1999, moved here, and the bleaching hit. I had no idea what to do to deal with this bleaching. But WWF flew me down to Kondavu, down in the southern part of Fiji, and I was just like, wow. Never seen anything like it. It looked like a snowstorm. But then 1 out of every 5 or 10,000 corals was still okay, not bleached. So I said, a little bit of that, a little bit of that. There are some of many species that are surviving. Maybe it'll be okay because there'll be enough surviving that they don't get wiped out. But I was wrong because most of those corals that did survive, these are the acropa corals, these are delicious. As far as if you're a crown of thorn starfish or a coral killing snail or a parrotfish, they love to eat live coral too, by the way, a lot of the species anyway. And the butterfly fish, they rely on these corals. And when they were cut down to 1% or less of what they had been formerly, they were attacked by all these enemies who were not overabundant when there was thousands of corals everywhere. But when the corals died off, the predator to prey ratio was skewed, and there was just not enough coral. They got all eaten up. So I learned a thing or two. I said, wow, Next time, if that ever happens again, and it did, what we need to do is we need to focus on saving those corals that survive. And nobody is doing that, okay, that I know of. It's not in, I just published a paper that says, finally, this year in January, I published a paper saying that's what we need to do, okay? It's just logical. So all these years, I've been doing this longer than anybody else. And by planting corals, I have gone from like a farmer approach where, numbers of corals are important, numbers of corals planted, the size of the area you're outplanting. And now I'm focused on something very different. I'm looking at an ecological approach where how do corals return naturally to the reef, and how can you accelerate natural processes of recovery? Yeah. So you restore the natural processes. You don't restore the corals necessarily, you don't plant corals over the whole reef. You can't, it's too big. So you don't focus on restoring that reef like that. You focus on restoring the natural recovery process. And so, okay, when it's all broken up, okay, the natural process is arrested. You cannot recover because of the broken rubble. That's the time when you do throw down branches of corals that are big enough to bump around in that rubble and start to grab on and hold on and cement it all together. So you can then, that is actually, and you don't want to necessarily do the whole rubble bed, but patches here and there. And then so you can get some recovery. So that is where a direct planting causes a change in causing natural recovery. So when it holds those pieces together, so a big coral branch, that it becomes a colony, and it can hold branches together all around it, and then it starts spreading. So you don't have to replant the whole thing. You plant patches that will naturally fragment and hold it together. And then once they're there, well, if a cyclone comes, they might blow away like a tumbleweed. But then I found that then they blow into the sand flats, and they're big enough colonies, like a tumbleweed, just tipsy-turvy. This is what happened in Puerto Rico. And these big colonies mostly land upright because it's heavier on the bottom, and they're just planted in the lagoon now. They planted, Mother Nature planted herself. And my hypothesis is this is how patch reefs start. Like in Bahamas or wherever, that the branching corals are like a tumbleweed, the ecropora corals, and then if they're on rubble like that, they are not very well anchored, and they will actually blow away. Okay, and they will go to new places. And it was a Puerto Rican fisherman who was the guy, working in the university on the boats, who said, these corals at Torremote, they used to be over here. And then the cyclone came, he told me Karen or whatever, and then they were over there. And the other professors were rolling their eyes, and I said, really? And he was absolutely right. His observation was correct, that these corals, staghorn corals, if they're on an unstable substrate, can just uproot themselves and blow away, and then you got a new population. So I recorded that happening in Puerto Rico when Hurricane Hortense, a tropical storm, came by during my study. Anyway, so that's manipulation. You can actually help Mother Nature to do that. So, but if you're restoring your rubble bed, if it's in an area that gets swept by strong currents, it may not be that permanent. So then we've created these cement structures that children are making. Looks like an igloo. It's called a fish house. It has doors and windows on it. Turns out if you have a big door and that's the only door, maybe a porcupine fish or a balloonfish will like to live in there. If it has just one little hole, an octopus might occupy there. But if it has, you can actually design them to make habitat for different fish. We usually put a hole on the top because we want to plant a whole coral colony on the top. So these fish houses, they can go into these rubble beds, and they're stable. So, and they will recruit babies to the sides of them, the corals. So this thing of blowing away in the hurricane or currents, there was a woman, Helen Fox, who did her PhD in, I think it was Indonesia, the dynamite fishing grounds, and she communicated with me, and she was having a problem. She was doing the drop and scatter method I used, but they would always get blown away before they would actually take hold. And so what she ended up doing was taking big rocks, filling her boat up with rocks, volcanic rocks or whatever she could get on the land, and just scattering those rocks in the rubble zone, and that's it. because then the coral larvae could settle down on something strong and stable, and you ended up with all these patch reefs. So there's this other group of people called the reef ball people, Todd Barber, the reef ball development group. And the reef balls are an excellent structure if you have a obliterated, mobile, rubbly reef that just won't restore itself, recover. You can actually create these artificial structures that have bigger holes, and they can be quite big or small. They have all different molds, and you can mass produce these, and you can scatter them in this rubble zone and just leave them. And Mother Nature will take, this gives fish habitat as well. And what we do, would we like to plant the staghorn corals on those, is like an anchor. It keeps them from blowing away. And why do we put the staghorn or some of these digitate corals on them? It's because, yeah, they will probably come on their own, but without fish grazing those reef balls or these concrete fish houses, without fish grazing them, they get an algae cover that repel the larvae. Coral larvae don't like that. So if you put some structure for the little fish to stay there, the little rabbit fish, the little parrotfish will clean that structure and make it ideal for the baby corals to come. Okay, so in all this work, I've learned that if you want to restore a reef, you need to get the fish population back. So the fish population is very important in keeping clean surfaces. If your reef is dead and you don't have fish, it becomes yucky and full of algae, and the coral larvae can't come. Okay, but if your reef is dead and you have some structure for little fish, where you create structure, or if you're going to replant corals, for most effectiveness, you'll want to plant them the kinds of corals that can hold the type of fish that clean the stones, and so they'll be in that colony, and maybe they'll clean around it, and so then the larvae can come in and settle in there. So instead of planting lots of reefs, we just basically look at the problem. If the problem is a lack of recovery due to unstable substrate, we deal with that. Okay, if the problem is a lack of recovery because the algae are all over the reef and the larvae can't find it, we deal with that. But in all these cases, fish and corals both are needed to reseed it, or to cause this, what we call a nucleation patch. Now, I during COVID, and a lot of this stuff is, I have all this stuff and it's all coming together. And during COVID, I was here at the farm, trapped at this farm in Fiji, and I had time to research. I said, people have been paying lip service, coral restoration we should be looking at plant and forest restoration and seeing what they've learned and see how it applies to, and people talk about that, but they rarely do it. So I actually read the new literature on tropical forest restoration, and I was surprised. Okay, that the old models of reforestation is where you just take these pine trees and you plant them, how many, you just basically cover the area and it grows up as a monoculture of trees. And that's what we were doing basically with corals. Okay.
Right.
Yeah. And so, so that model is an old model. It's been proven not to be very good for the ecosystem. Okay. And it doesn't take advantage of natural robustness. It also sets it up to be killed by fire or a storm. It's not very resilient, what you get. And so it's not very diverse. So what they're finding out with tropical rainforests, when they've been destroyed, like by clear cutting is not good for tropical rainforests. It never happens in nature. You'll have an old tree will die, or a lightning strike will kill a tree and that will fall. You'll have little clearings will be formed by indigenous people, which are then abandoned, and then they'll do another one and they'll come back to that one or whatever. So you have these forces of nature and people being part of nature for tens of thousands of years. So we have the tropical rainforest evolve with these small clearings and just little patches. And once you clear cut a forest, oh my gosh, something is different. And here in Fiji, this big vines with big giant leaves, Marimia peltata, comes and it covers the land. And it basically becomes a vine, just a field of vines that doesn't recover. And you cannot do clear cutting like they're doing in Borneo. Now they're replanting horrible oil palms, which, and that sort of thing. So every time we are eating palm oil, most of it's probably coming from killing orangutans in the rainforest. Now, in the Solomon Islands, they are starting to do that. And other places, they're starting to do oil palm. I don't know about Brazil yet, but I wouldn't be surprised. I bet it's happening. But when they deforest the rainforest to put cattle in there for McDonald's or whatever in Brazil, it doesn't come back because it doesn't come back because the seedlings are developed to be in, they're shade-loving seedlings, right? And they like partial shade. And so it doesn't come back on its own very well. It creates an alternative steady state condition, usually a grassland or a vine-covered field that is not very productive. And, you know, anyway, so how do we fix the tropical rainforest? People discovered that if here's the degraded area and here's your rainforest, you have your rainforest here and they see it does slowly expand. And how does it expand? They say, hey, it expands by a little patch will form in a little sweet spot. There's a bush here. So a seed is, a bird sits on that bush and poops a seed of a bigger tree. And then that starts growing in the shade of that bush and it grows up. And so you get a little patch. It's called a nucleation patch. So that rainforest will reconquer that degraded area very slowly through these nucleation patches that are in the front line. So what they've decided, hey, let's try to recreate that. Ooh. Right. Okay. So they basically have discovered that they can recreate nucleation patches. So instead of the old model of they take those failed model, they take those in nurseries full of mahogany or whatever tropical tree, and they'll go and plant 1,000 of them or 10,000 or 1,000,000 of them. And most of them will die. Yeah, most of them will die because they're planting these little trees. Most of them will die. Or in Fiji, we can plant this Pinus caribea. It comes from Honduras. And that pine tree can actually survive in that light, bright light. And it's a bit fire resistant after it gets a little bit bigger. So we have now our degraded tropical rainforest has been replanted in the West with pine trees. And we're finding that those are actually more diverse than the mahogany forest they planted, because mahogany is full of tannic acid, which suppresses all these plants. It's got some biochemistry that's fighting and competing with, okay? But pine trees, the pine trees have a lot of resin in their wood, but they don't have a lot of resin apparently in their needles. And so these pine trees, you have tree ferns in there, you'll have, you know, the native plants, not many epiphytes, but you'll have native plants will start coming into the pine forest because it provides the shade that those trees can generate in, okay? And pine trees are kind of like a pioneer species, right? Yeah. And then even in Honduras, you know, where the tropical forest, tropical deciduous or broadleaf forest comes in, and wet, dry deciduous. Anyway, so back to this again. So here, instead of planting 10,000 little seedlings, they found out if you grow in larger pots, trees that are 2 to 3 meters tall, and you only plant 100 of those in 2 patches or 3 patches or 4 patches. If you just plant a few taller trees, because at that stage they can survive in higher, brighter conditions. And if you can plant just a few bigger trees, you are going to get a better success than if you plant 10,000. So to replant the rainforest, it's basically you create a nucleation patch. So with those trees, oh, here's a bushy area. Oh, here's a little gully where it's got, you know, already bushes, and oh, here's a seedling that's already growing. Let's go and reinforce those areas that are sweet spots with these few trees that we have that are bigger. And those trees will grow up, provide shade. And the key thing is, critical thing is, they're already big enough. And if they're not quite big enough, they're only 2 meters tall, they'll put a perch that's 3 or 4 meters tall. They'll create basically a T shape. They'll put in a perch there for the birds. Okay. Now, because if they can attract the birds to this patch, the birds will sit there and poop. And that fertilizer is very important for that patch. Yep. Plus, those birds then attack the insects, the caterpillars that will gobble up those trees. And so you have a natural predator there now protecting that patch. So, and then that patch grows. And so the birds are critical. They bring in the seeds, they remove the enemies, and then they start nesting and that sort of thing. And so it's a very, very good habitat for the birds, and that becomes better habitat for the trees. And then you'll have things like the rats are eating the seeds and preventing them from sprouting. Well, then you'll have predators of those rats will come in, and maybe hawks will come and perch there. la, la, la. And so you have a very diverse little microcosm of a tropical rainforest will start there. And so, and it grows, it spreads. Okay, so if you do enough nucleation patches, you basically have restored your rainforest. It won't take but a couple of generations or whatever, decades anyway, before that rainforest leading edge. And it's good if you don't have a leading edge, where are you going to get those birds? Because you need those birds to come over, right? So
they have to come from somewhere.
Yeah, you have to come from somewhere. So you're trying to find a place, and the bats will come as well. And bats carry big seeds. You know, they're fighting with other bats. So they'll say, oh, there's a big giant seed here. I'll carry it over here and sit and eat in peace. So basically back to coral reefs. Well, we don't have birds on coral reefs, but we have fish.
Yeah.
So if the trees are the corals, then the birds are the fish. And so during COVID, I said, wow, okay. So here and that's why we want to put in our patch, we want to start with the trees, with the corals that are the best habitat for fish.
Yep.
Okay. We don't want to deal with these massive corals, which are very stable, very strong in cyclones, very resilient. We don't want to necessarily start with those. We don't have to. We want to create the conditions by which those real resilient corals will come in on their own. Okay. So you won't plant a Brazil nut tree in that patch because it likes a darker shade. But you know that will come in on its own, or you'll throw a few seeds in there later on if it doesn't come in on its own. So you have to realize that the natural processes start with a pioneer species. And in this case, it's a species that can tolerate those harsher conditions that are away from the reef. Now, the positive thing about being away from the reef is the coral killing species. If you have it within a certain distance, the butterfly fish won't go there because they're afraid of crossing that empty space. The parrotfish that might chomp away at the tips won't go there. The crown of thorn starfish, they won't venture out. You know, why would they? The triggerfish that take these digitate corals and blow them up, looks like a firecracker was in there because there's crabs and shrimp living in those little corals, and it looks like they blow them up because they'll just go and tear the coral apart. Those won't be in there either. So you'll have a little refuge, your nucleation patch becomes a refuge for, and maybe the birds do the same thing with their nests. Maybe it is a bit of a refuge in these rainforests. I'm not sure. So you create a refuge that will attract the fish that you want. And the fish that you want actually come in as tiny little larvae. They won't cross that expanse to get there. And so you want kind of 10, 20 meters away is good to prevent the predators. But even the fish that you want, they probably won't find that because it's too far away. But they come in as little babies, and it's good habitat. And the groupers that eat these little things, and the jacks and so forth that eat these you get plankton feeders on the top, the little blue fish, little chromas, and the black and white fish in there. So you get all these plankton feeders taking the plankton. So instead of the birds fertilizing the trees, these are the plankton feeder fish up here above the colony. They're going, here comes something big. They go and hide. A jack comes because jacks can come visit that. Snappers even can. The bigger snappers they're not afraid. They'll come and visit that. And those plankton feeders will go and hide, and they'll pee in the corals. And those plankton feeders not only pee in the corals, but they're doing other things. The little tails are dusting them if it's a silty condition. They're just the moving in and out. It hasn't been studied, but I'm absolutely positive that it's a circulatory system of coral. So once you have a heavily branched coral, there's a lot of space in there that's pretty well dead space as far as currents. The currents go around them, not through them. And I'm sure that this movement of fish in and out is a circulatory process that corals have evolved with the fish, and they can be very highly branched and very, very deep with those branches, and the coral tissues can stay alive even way down deep if these little fish are in there moving in and out. And then these other fish move in. They're called a farmer fish, the Stegastes fish, the brown damselfish anyway, that come in and they will start killing the coral on the bottom and planting little algae. And so they don't actually plant it. They know the algae comes in and they weed out all the bad ones and they leave a few. The kinds they like to eat, these little red algae, will grow all in the bottom. So here your coral, you have all the parts dead on the bottom now because the farmer fish is living there and this is his farm. So as this gets big enough for the predators to come in, that farmer fish will chase away the parrotfish. Get out of here. Don't touch my algae. So the parrotfish won't be able to bite the tips of that coral. Butterfly fish comes in and it'll chase the butterfly fish away. Don't touch my coral. And here comes a crown of thorns starfish coming over. Ooh, I can smell you over there. I'm going to come and eat you. And it'll take the thorns and bite the thorns right off and scare the living daylights out of that crown of thorns. It'll flee. So these little farmer fish, while most scientists, oh, it's bad because it's killing the bottom of the coral. And it can also spread coral disease. Okay. If you have a diseased coral, they tend to spread it. And while it has a negative impact, it also is extremely important in keeping that coral alive. So I've been studying all these years, this deeper ecology of natural recovery, natural processes, and how do you restore a system that's damaged and deal with why is it damaged? Was it a cyclone? Was it a bleaching? Was it overfishing combined with those things? And it's usually a combination of factors.
Combination, yeah.
Yeah. So basically, if people can read my paper, I don't know if you can put the link up or whatever, but if people can read that paper, it's absolutely revolutionary because it's a break from the old model. And most people are still stuck in that old model where they think that numbers of fragments, if you're going to plant 1 million corals, as if that's going to help.
It's like planting 1 million, but it's like planting 1 million trees and most of them are dead.
1 million pine trees won't save the tropical rainforest. Or if you plant 1 million rainforest trees, they're going to die.
Right.
So what we're doing, we used to plant, when we do make our nucleation patch, okay, we used to plant, whole colonies from the nursery, and that was good and everything. The problem is, it takes a while to grow them up. And once they grow up, they also spend tremendous amounts of energy on spawning during spawning season. So the growth rate is very slow on those big colonies, but at least it's instant habitat. So initially I started doing a few nucleation patches of these big colonies from the nursery. And then the coral gardeners from Moorea came and they have the old model, but I'm helping them. And they say, but it's easy to understand, plant 1 million corals. So we have people can sponsor that one little branch and pay some money. And the coral gardeners have raised all the money they need. They don't have to go and beg to a donor. They've gotten the money coming in through this plant, sponsor a coral program. So their model requires numbers. And I said, well, okay, I'm having a problem anyway, because these larger colonies are growing slowly and the nucleation patch is spreading slowly. So I thought when they were there stirring me up, and I said, okay, let's try this. So we've already been doing these A-frames. So we have these the standard floor mesh, heavy floor mesh that have these 20 centimeter squares. We've been planting these corals on that with the children in the resorts and so forth. And it's a good way of doing this. During COVID, we had done 4 of those. I had a group that came from New Guinea and Samoa. We went to Naidiri village on the Coral Coast, and we planted 4 of those to see how it worked. And we just used branches like, little branches this size, maybe like that. We planted branches on each of the junctions, and we left them there. And I was gone. It was COVID. I couldn't even go there. We were locked down. No planes came to Fiji for over a year, almost 2 years. And I couldn't go to the villages. You weren't supposed to move around. But anyway, when I did go, they said, oh, Austin, come, you have to see this. Something amazing. Okay, so I went into their A-frames, and they have a hole down the sides, and comparing, I couldn't believe it. The corals had gotten huge, and you couldn't even see the frames. They were coming out, huge on all the sides, staghorn corals, multiple genotypes, huge, and they had almost reached the surface at low tide. And you look inside, and inside there were just dozens of beautiful big fish, mostly red squirrel fish that were hiding with big eyes, looking at you like, oh, somebody's looking at us. What should we do? We can't run out. So they'd go to the other end. And so we had created a fish house that was a wonderful habitat. And the community said, wow, we want to do 100 of these, because it was a no fishing area, right? We can't catch these fish, but we want to put some in our fishing ground too. Okay. Now, what happens with those are night active fish that were sleeping in the daytime or hiding there in the daytime. Mm-hmm. At nighttime, what happens? The parrotfish and the surgeonfish, which are so critical in keeping the reef free of algae, especially the surgeonfish, they were going and hiding there in the daytime. So there's this shift and it's like a work shift. Okay.
Work shift, yeah.
The whistle blows and these guys go in and these guys go out. It's a 12-hour shift. And so we created fish habitat, which greatly increased the carrying capacity of the no-take area for reef fish. Now, that needs to be studied because, will it drive down certain other species, or whatever, but it's a clean reef. It's this whistle clean because of the algae eating fish. Anyway, so this is the traditional thatched house here is called a bure. So we call it a fish bure because it looks like a thatched house, right? Thatched with coral. So now when the coral gardeners came from Moray, I said, well, we can do that with this, and instead of one colony, I'll break that up into 40 or 50 pieces.
Yeah.
We can count each of those as a sponsored coral that you're planting, but we plant them together in a group on this structure, which the structure gets so covered with coral tissue that it doesn't rust. We coat it with phosphoric acid. We like it to rust. We coat it with phosphoric acid. Then it won't rust anymore, and that's because it gets iron phosphate. It becomes black, full of iron phosphate. We have some in Belize now that are over 12 years old, about 12 years old, and they're still there in the water. Okay, so they don't rust and fall apart if you treat them properly. Anyway, but you have to anchor them if there's a lot of current. Anyway, so that's a method. But back to the thing is, I changed my methods. The nucleation patches now are using an A-frame because I want fish to come as soon as possible. So if there are any roving schools of surgeonfish, they would find shelter there and so forth. So, and it doesn't matter, even those squirrelfish, just the movement of their tails will clean the silt out and so forth. So the nucleation patch needs to have the fish there. And so we're looking now on how do these fish houses work, these fish bures, these A-frames, as compared. So some experiments showing the same number of fragments planted traditionally, cemented down onto the reef versus this thing over a 3x3 square meter area, which is better for cleaning the surface of the reef so that larvae can come in, which is better for attracting fish. Okay, the numbers of fish, the size of the fish, and we know that the A-frame will do that better. But and also which is better for survival. And I believe the A-frame will have much higher survival because you're basically taking something that's juvenile, you're clustering it, so it can grow gangbusters. It can grow very, very fast, and it can enhance other little ones to become fish habitat much faster. And what we're doing also, we divide the A-frame into sections. So we might have room for 6 different coral genotypes of a species. So we put all one genotype on that part of the frame so that it grows very quickly over 1 year. Then they kind of merge together. They can actually fuse, and it becomes a single colony with multiple connection points everywhere. It just basically covers the frame. And because they become one single colony, they start reproducing sexually on the 2nd year, because they're already an adult. So you can jumpstart the adulthood by putting juveniles together that will of the same genotype that will merge, and adulthood basically is related to the size of the colony. So you basically created a super colony that's like, it should be 5 or 10 years old. Okay, even though it's only 2 years old.
2 years old, yeah.
Yeah, and so you have the rapid growth of juveniles, and you have then the accelerated reproduction because they merge. But if you did haphazardly, all the different genotypes, they'd fight with each other when they join, and they won't become a super adult very quickly. They'll be spending so much time fighting, they won't grow very fast either. So this is the other thing. This is the other thing with corals. If you plant corals that are of different genotypes together, they will fight, and they will compete with each other. So on microfragmenting, we did some microfragmenting where you put a cement ball and you put little teeny pieces together. So if you put all from the same mother there, they'll all merge together and just grow into this beautiful colony. But the same age colony that you put 3 different genotypes all together, they're so busy fighting that they're not even establishing themselves. Okay, they're just it's like a bunch of children, fighting. They're so busy fighting. They've thrown their food on the ground, they can't even eat. And they're just so busy fighting and competing with each other that they can't cooperate. So putting them all from the same genotype, they recognize each other, they merge, and they turn into this colony so fast. That's the importance of microfragmenting. But if you mix the genotypes together in your microfragmented area, you got big problems. So we have done that, by accident, actually. So we are learning all these things. I've tried to put as much of that as possible in that paper. We're trying to develop a second paper now that looks at proof of concept. That was just theoretical, and now what we're actually doing, and try to get proof of concept now very quickly so that people will believe us. You can see this happen, you can see that happening. People, if you see something happen, no matter how many times and how many people see it happen, if it's not put in as a scientific paper, people won't believe you. Oh, that's just your observation. But in the old scientists, like Charles Darwin, he went to Galapagos and he just drew pictures and he just described what he saw, and people just accepted as gospel truth. People describe the forest of the temperate zone, and we have so much more information about that, the deserts and so forth. And this was just descriptive ecology, and it wasn't experiment based. It wasn't hypothesis testing. It was just observations. This is eating that, and that is killing that, and that is protecting that. And it was and people believed them. So I'm trying to get some of that together and say, well, if you don't believe that this is what the world according to what we've seen, and graduate students can do experiments on that if they want to verify it with data that wasn't just descriptional, they can. But we need to get it out because we've seen it so many times. We know it's true, and And when I went and did my thesis, I had done so many experiments. I knew what was true and what wasn't true. I did 10 different experiments, and the professors said, "Oh, don't do that because it's like a whole bunch of pilot studies, and you probably won't get any significant things. If you're doing a replication of 10 for each of these 10 experiments, you might get a bunch of garbage." And I said, "No, I won't. I've already done these experiments in the Pacific, and these are staghorn corals, and they'll probably perform very much the same." So every one of my 10 experiments showed highly significant statistically, and I already knew the result basically. And so I wrote up my thesis, and my professor said, "Wow, that's just so it's unconditional. What do you call it? No, it's abnormal. Nobody ever does it that way." So my thesis looks like a whole bunch of pilot studies, but they weren't, because I already did the pilot in the Pacific. So I didn't need to over replicate. So if you have the difference between two different things and you put 1,000 replicates, you're going to find some statistically significant difference. But will it be ecologically important? It's statistically significant, but is it biologically significant?
Right.
Or is it ecologically significant? Maybe not. Okay. Yeah. So why are you doing 1,000 replicates, wasting your time? Because there's a difference between me and you, but who gives a damn? Okay. Because it doesn't mean anything as far as we're trying to save the planet. I can go in nature, and it's not symbols. Okay. I can actually go in nature and see these things that other people won't see the connection to, and I can see how it connects. So I didn't really understand this. I always thought I was a very poor excuse for a scientist. I always thought I was, masquerading as a real scientist. I did. I mean, that's the way I was made to feel. Right. Because there are people, the best people in coral reef science, that go to a meeting and they're all, and you feel like, oh, and people still talk down to me all the time. Even people that are just working on their masters, because I'm just a normal guy, and I'm borderline autistic and ADHD, whatever. And you could probably see from this, I have a hard time holding one thought.
I got a bit of that going on too.
Yeah. So, but I'm telling you, if you're not good at what the other scientists are, stick with it, because you have qualities that can tease out truth from what other people can't. People are like this, and here we're like this, right. and this is not going to save the world. Okay, it might contribute to saving the world, but they won't be able to see the new things that need to come into the solution. So I only recognized this about 3 years ago, that I really realized that I could do things that other people couldn't.
Yeah.
We had a master's student in our site who was trying to find a topic. We had local marine biologists that were working, and we had this big coral nursery that had been plopped down by people from Australia who I was working with, that were very demanding. Oh, this is the way we have to do this. Instead of fighting them, I said, okay, we'll put it here. even though we haven't tested the site, even though we did kind of have a site that failed there before, we'll still do it because they're kind of bulldozing. Oh, work. And so I was like, I don't know, not very committal. But anyway, I went back. I got a phone call. I was here at the farm. Oh, Austin, come help us. There's something problem. And what was happening, this horrible Lingbia algae, this horrible cyanobacteria, which is big as my beard or bigger and black. And it was on the reef flat and the seagrass, and it was just lifting off, oxygen bubbles forming there. It was an epidemic, and it was coming over to the corals and the staghorn corals on the ropes, the branching digitate corals, the tabulate corals. Everything was getting snagged with this floating Lingbia algae. And it was so covered that you couldn't see the coral underneath. It was smothering. And, these corals look like Cousin It in the movie. Seriously, you couldn't see them. And these poor girls, a team of 3, were pulling it off the corals. And we had over 200 ropes. And we had all the corals on cookies on the nursery. They were trying to take this Lingbia off. And it would take 45 minutes per rope, they calculated. And then it would come back within a week because there were still little pieces left. And I knew when I went there, and a lot of corals had already started to die. And I knew this was the end of this project, the end of this nursery at least. And I realized this was really going to be a blow to the program. And I just detached my mind and I said, there's an answer out here somewhere. So I just detached my mind. I left them struggling there, crying in their masks. Really, they were really desperate.
Yeah.
I left them, and I hovered over the reef and went over the reef. And instantly I say, where's the Lingbia on this reef? A little bit there, a little bit. There was hardly any Lingbia on the entire reef. I said, something's going on here where our nursery and the same species of corals are clean on the reef that are just absolutely being smothered in the nursery. The nursery's only 2 meters away, 3 meters away from the reef.
Huh.
What's going on? So, immediately I saw that. And because maybe my mind was, looking like this, right? And I said, okay, now what is that? And with just like that, I said, and I said, these farmer fish are doing something because I know that they weed out their own algae and throw out and that's how they cultivate. So basically, I took a handful of that yucky Lingbia, and I put it in a farmer fish territory and just went back and watched. And those little farmer fish really went to town, and they took it and they grabbed it, and they were fighting each other for it, really, and to throw it out. And they threw it out about half a meter away on the sand. Sometimes they would take it and throw it really down deep in underneath all their algae down into the dark where it would smother. Okay, and they completely eliminated it. So I called the girls, said, girls, come look what I've just found. So and they were like, oh my God, wow. So what we did, and Annalisa says, I got my thesis topic. So the graduate student from University of Miami, we tried one rope that day and saw them clean it off. And the next morning we had to take it out because they started to nip at it. They said, let's plant some good algae on here. They started to try to damage it. So we had just a little bit of time, but we had to take it out, put it back in the nursery. It was so much cleaner than we could have possibly gotten it on our own. So all those 200 ropes, we had big areas of farmer fish, and we put them all. She got her thesis, putting them far, putting them close, putting some on the sand, la. And she got great data and very, very quickly showed that these farmer fish are the absolute best gardeners. And so we got the farmer fish working with us and helping us to save the corals, and it saved the day. And so I realized that I could figure out something. I had a lot of experience too, but my eyes were open and I could see that where they were so worried about the problem they couldn't leave that. Okay, we got to keep doing this weeding. Now that we had cookies on the big table, that we had a hard time going in the farmer fish. I said, there's got to be another solution for that because anyway, so when we were cleaning, now and then we get this burst of bright purple, magenta color would come out of this stuff, and we'd look, and it was a little teeny slug, and it's called Stylocylus. That's what the graduate student found on the internet very quickly. Stylocylus is the only, the main thing that eats that Lingvia. And so the Lingvia comes too much and Stylocylus then will, population will boom and then get it. So I said, well, there's got to be some Stylocylus out here that we could put on our main table. So right away, I went and swam out into the seagrass, and around the point there was coming like this herd of Stylocylus. I have never in my life seen anything like it. There was just a front where there were 3 and 4 deep, just all trying to come in and grab the next piece of Lingvia that they could. And there was a feeding front, a frenzy going on of these piranha-like slugs. They're just kind of brown, but they have this purple ink in them. So I basically took a sack. I didn't tell the girls about it. We had a potato sack out there. So I just put it down and I shoved them in. And quickly I got 2 sacks of these. And I said, girls, come here. And so I just emptied them out onto the table, and they just came down like snow on the table. And they were like, Dr. Austin, how do you do this kind of thing? And I said, I don't know, I don't know. And so it's just like Mother Nature we were working together, and it was just like all this things were clicking. And so they cleaned that entire table within 24 hours and then went off looking for more Lingvia to consume. Okay. So that needs, and that paper hasn't been, that the master's student, Annalisa McDougall, she published that. No, she didn't publish it. It's her thesis, but it hasn't been published yet. So in the publication we're going to put key elements of that in there so that people know how important this is. When you have this horrible problem with cyanobacteria, these cyanobacteria, the what do you call blue-green algae, in your nursery, which the fish won't take care of, you can then use your farmer fish as a backup to help you. And this can really be important in making a project that would otherwise be broken to keep it alive. And so these farmer fish have been labeled as bad, and because of their protectiveness of the coral, I have seen that if you have a mass bleaching and it kills all the reef, like what happened in 2002 in Fiji, it kills off most of the corals, but that 1 out of 2 or 3,000 corals that didn't bleach, didn't die, its days are numbered because the predators then will attack it. But if the farmer fish happen to be there, that coral has a very good chance of surviving. So the farmer fish, I believe, will be critical in keeping species alive post-bleaching because it is protective. More than the damage it does, it protects the coral. What I'm with the farmer fish, what we've noticed also is we had in the Caribbean with the Acropora, the staghorn coral, you can grow it in the nursery like I went to Dominican Republic, I didn't come back for a couple of years. The corals were huge on the nursery, still floating on the ropes, and they were still alive all the way to the bottom. But there's the Acropora, the staghorn coral of the Caribbean, is really in 2 different groups, and I think it's 2 different species. And I found this out when I did my thesis, that they have a fat one that lives on the reef front that's high energy adapted, that has indeterminate growth. It can keep growing bigger and bigger and bigger. And in the past, it could get huge, this big around in the Caribbean, and you find it in the. I found one piece in Honduras. I found some that was that big, and also in Dominican Republic. But it keeps growing really tall. It can be over 2 meters tall, and it's not so heavily branched. And I believe it's a different species because the others, and you don't have much of an integrated between. Then you have the laguno species, which is thin branches, never gets bigger than that. And the one species in my experiments, it always feeds its bottom. It feeds its base, and the base is always strong. It does not senesce. But this thinner one, the bottom of it doesn't feed the bottom. And when it gets really big, when it gets over 1 meter tall, its bottom starts to die on purpose. And I think it says, well, farmer fish are going to be down there, and why should I send resources down to where the farmer fish are? And so I just kind of abandoned that area because the farmer fish are going to be there anyway. So I think farmer fish evolved with the one, but not with the other. And the wave energy was with the one and not with the other. So either it's a new species or it's so different that they're evolving into new species. And with the elkhorn corals, they found out there's actually 2 different genotypes or varieties of elkhorn. So, and then they found the cross between the 2 is the fused staghorn. So the Caribbean has supposedly only has 2 species of Acropora, but I believe it has 4 potentially. And so it's because ecologically, each one is very distinctive. So, and so if it's an ecological species, and also they're separated for breeding purposes, they're pretty much separated. So, so the Caribbean doesn't have that much diversity, but I think because of that, the species that are there are evolving rapidly to take advantage. But anyway, that's a different thing. So, but to get to this point, so we used to just trim the corals in our nurseries and take branches and plant those, leaving the core to grow back again. But we found that with some of the species, the bottom tends to die. So we're going to end up with dead parts touching the rope, and so that those can get rotten from sponges and fall off. So we're no longer trimming those colonies and leaving the middle part. We're actually we just take the whole thing off. We break those up or whatever we're going to do, plant whole colonies, whatever. So we basically, and what we're doing is we're weighing it. So you know how for my thesis, weighing it's so tedious to get growth rates on corals by measuring length. And then it's just that way, or do you want to do the branching? And it was so much work. So when they're doing measuring of corals and they take photos and then they compare them, and that's a lot of work too. Maybe A1 will help with that, but this is what we do now. And because we're too busy, we plant a rope, we weigh it, okay? And we weigh it next year when we harvest it. Oh, that's 4 kgs of coral growth, or that's 12.3 kgs of coral growth. And then we trim enough to go back on a rope. So in our gene bank nursery, we replant with fresh branches that are about that big. We replant with fresh branches, and then we go on and outplant everything that came off on that other rope. So, so we're doing things in a more methodical way. So if you want a large colony, here it is, okay? Because so from a branch like this, typically in a year, you'll get a colony like this, okay? For fast growers, you might get a bigger one even, okay? So, but if you go with a little one like that, you're not going to get something very big. So, so we need to do basic growth. We have some research that's missing. We need to do a growth curve, because little babies grow very slowly. With humans, with animals, with trees, little babies tend to grow slowly, and then they get to this juvenile stage where, whoa, they grow really quickly. And then as adults, if an outer space person came and measured you and me, they'd say, ooh, these are ancient beings. They're only growing a little bit around the middle, So as adults, we don't grow much. We actually shrink, and we only grow in other parts of our anatomy. But so with corals, I believe it's the same. So they have very rapid growth, not in the beginning. They have pretty slow growth because they have to spend so much energy just in defending themselves from the environment, because they're with all the yuck, okay? And how many of them survive? The survival rate is very low for the little juveniles. And so they're spending most of their energy on just holding their own. And after a couple of years, they're only this big, okay? And little discs, and then they rise up in the middle. Once they reach the juvenile stage, whoa, they grow really fast. And then as adults, they throw away most of their energy in spawning. So large amounts of their body. Somebody said as much as 40% of their tissues can become sperm and eggs. I can't find that reference, but we need to redo those things. What percentage of their bio tissue actually becomes sperm and eggs? It's a huge amount. And if that happened to us, if we spent that much energy in spawning, we would die. Okay.
Yeah.
But anyway, so there are so many unanswered details. And so what we do is, instead of using the small branches, now, if you're going to do microfragmenting, that's different, because you're using those juveniles to fuse very rapidly into a larger colony. Like, suddenly you have an instant 4-year-old colony or 3-year-old colony. And because you're taking that, they're growing. They're not growing that fast. They say it's 20-fold, blah, 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 blah. But actually what's happening is that growth is when they actually merge, that the growth really expands.
Right.
And maybe in between, they're actually able to do, they start anyway. But anyway, so people need to do these growth curves, and the best way to grow little things is to put it on a little, you can use underwater super glue, and you can actually cement things on fishing line, and then put the fishing line hanging on ropes. So you can grow these little things on fishing line, and they'll stay pretty clean and everything. And but somebody needs to look at each species, and some species are going to do very differently than others. But we used to use small branches, and we find that in our yucky environments in the near shore, they don't grow very fast. And so when we put little branches on an A-frame, they tend to die. And once we get to a certain critical point, that's the size where they hold their own, but also they're able to have enough. Their immune system is reactionary. It's not a learned immune system. It's a very different immune system, but they do have an immune system, but it takes enough tissue biomass before they get really strong against all the pathogens. So the little guys are going to be disease susceptible. The bigger guys are going to be more resilient. And then they're also going to have a lot more energy that they can focus on the tips, because all these photosynthesis can be focused here now, and boom, and they can grow big. And so you're trying to get something, you're trying to maximize growth, because you need that growth in order to continue with your work. Okay, so, and instead of planting it randomly where most of those little guys are going to die, no, you can create small guys, but you want to isolate them. That's why they're good elevated on something. So you could, if you don't have an A-frame, you could plant them back on ropes and do a whole bunch of ropes in a nursery and head start them into colonies this big after 1 year and plant those. So it doesn't matter how you do it, but you need to know the basics of coral biology and growth, and the growth ecology and the reproductive ecology and everything else of those corals, because you need to know the weak points that they have. And survival is critical, and growth rates are critical. And then if you want to keep it high growth rates, you want to prevent them from reproducing until such point as that's what you want. You want to restore, because that's the solution, is restoring effective reproduction. So when we put our small branches now on the A-frames, we know that they will grow really rapidly, then they will fuse, and they will spawn next year and start growing slower. But that's the point where they're big enough to hold their own, and we have different genotypes of the same species, maybe 4 to 6 genotypes on that A-frame. So it's the same genotype, so that there's a very good chance of fertilization. So this is what happens is when the Acropora corals become rare. Say, if here's one tabulate coral, okay, looks like a table. It's one. Where's the other one? Oh, it's a kilometer away. No babies, okay? If you can take a bit of that one and a bit of this one and do this cross transplantation, so now you have a colony of each of those beside the other one. Now you have fertilization, you have reproduction. Okay, so instead of replanting the whole reef, you should be thinking, oh, this is an isolated coral. Let's help it to reproduce. Leave it alone. And here's another one of the same species. Let's take some samples, cultivate them big enough. Let's plant them, cross-plant them, and now we've restored the reproduction. Okay, it's telling us, I'm happy, I've survived. Oh, look, there's farmer fish all around it. Okay, so you also don't want to be feeding predators. So we have sites where you plant the corals and watch them get gobbled up by parrotfish. So we made no fishing areas on the Coral Coast, way back, starting as early as 2000. The first no fishing areas that Fiji had seen in probably 80 years. Okay, so the government said, no, the queen owns the ocean, not yours anymore. We're in charge of it. So they had become Christianized. And so this custom of reserving the reef, of making tambu, it was a Pacific Island idea of closing the reef when it got overused. So they stopped doing that. They said, well, we can't do that. The government's in charge now. And they had some sacred reefs. They had reefs that had been from all time non-fished. Okay? Wow. And these were associated with their former belief system. So our two sites had areas that were huge, that were never fished. In the Mamanudas, it's Mamanuda Ivake, which is a huge island area between the Yasawas and the Mamanudas. It's huge. It's over 10 kilometers wide and broad, maybe 15 or 20 even. I think, more like that. So it's a huge area there. And then we have in Motoriki, our other maid site, we have Davatalevu, where is a huge sacred area, which they wanted to restore. But anyway, so these are two areas that are still being fished by people from outside, but those people who supposedly control it don't fish it, mostly don't fish it. So in the old days, people had a system that now the scientists are finding out, oh, this is the best way to manage coral reefs. This is the best way to keep healthy coral reefs and abundant fish, is to have these no fishing areas, okay? MPAs, we call them. And that was an old Pacific idea. They had rotational ones where it was temporary, and they had permanent ones here. all over the whole region. And so when I came to Fiji, we didn't work too much on coral restoration because the corals had never died. Okay, then in 2000 they did die, but we were already into the no fishing areas, and we started working on no fishing areas. And I had never dealt with bleaching. I didn't know what to do. And then that bleaching has come back again and again. And if you saw the BBC footage of all the coral work I had done, this beautiful corals, and there's this one on Wild Pacific. It shows the corals that we planted on the little cookies, and it shows them diddle-doo, 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 and growing big in just a 1 year time from just a fragment to something big, and the fish are playing on it and stuff. That all those corals died. Okay, and then it shows people planting on the reef in that Wild Pacific footage. And I was in the Coral Gardener, another one, and almost all those corals that we planted, they died in the 2014 bleaching. And then it bleached again in 2016. It got so hot, the fish died in 2016 in our site. And there was no corals left, hardly any. And so I got really kind of depressed about it. I said, well, everything I've done is for nothing. This bleaching is going to kill everything. And then I noticed that there was that one purple coral, the one that I held on the BBC footage, that didn't die. I mean, was it because I held it and I loved it? I don't know. But for some reason, it didn't bleach and die. And so then I started to think, well, what else is out here? And then I started to see that there were just a few corals that did not bleach and die. And therefore, we had some hope. So then I came to the conclusion that I'm not going to plant any more corals unless they've actually proven themselves to be survivors of a mass bleaching. So right now, we have a serious mass bleaching in the eastern part of Fiji. And the Lau group of islands, which have been, they've always in the past given us all the larvae because they've escaped mass die-off. They've provided all the larvae that we need when our reef dies, and the reef recovers pretty quickly. But now it's being severely bleached, and I'm afraid most of it's going to die, especially of the acropora corals, which are the first to go.
Right.
Now, in our site in Motueka, 99% of the corals, these acropora corals, are bleached in most of our sites. There's one site that's out on the Cooler Reef that only about maybe 70% have bleached badly. Okay, and if you look at these corals, here's a tabulate coral, right? If you look at the top, it's pure white, but if you go and look at the bottom, it may still be brown. The algae may still be down here in the shaded part. And now the waters are cooling off because the cyclones went by and cooled the water off. And now I think that coral won't die because it's able to get some energy from the reflected light down here, and it was protected from the UV and the heat down here. It didn't die. So now that coral is not going to die because it can be fed, and of course it's trying to eat plankton too. But the top part is white, and that coral over in the next few weeks, these algae are going to reproduce and going to repopulate the top. So the corals that are super corals that are unbleached at the top, the corals that are beautiful, still unbleached at the top, they need to be collected now because in the next few weeks, the corals that are half bleached are all going to look the same as the ones that are really and truly super. So we have a very short time now where we have to go back in the field and collect as many pieces as we can of these unbleached corals and bring them together into the nursery so we can work with proven super corals. So that's our focus now. And so we're running out of money in May. The UN Environmental Program project is finished. We don't know. We have global giving. It's about all we're going to have. So we have this critical point now. Fortunately, our main site, the one that in Malolo, it was bleaching very badly in January, and then it backed right off because of all the rain and clouds. So, and now these cyclones went by on that side, and it's not going to die. So we don't have to worry about that site. We only have to worry about our newer site in Malolo, in Motueka, in the eastern side, and getting those corals collected. So you can see how we have strategies going on. So this is the other thing. When we plant our corals, if they are indeed super corals, right? If they are indeed bleaching resistant, when we put them onto a dead reef, we're looking to reboot the natural process of the larval recovery. So what happens on a dead reef? Let's say here's a dead reef. It's been bleached so badly or a cyclone hit it. because the fish don't have much habitat, it's probably going to have this layer of yuck on it. These turf algae are going to be everywhere. And it's going to be silty as well because that turf algae traps silt. So here's your reef. It's not recovering very quickly. Maybe you'll find some big, massive Porites colonies because it's so strong. Or maybe even some finger Porites, which give a little bit of fish habitat. And around those colonies, maybe the reef is coming back because there are fish hiding there that are cleaning the reef. So by creating our nucleation patch in the middle of that dead reef, we're providing fish habitat by those corals that we're planting, and it's pretty much instant. So they'll come in as larvae, or they'll run over from wherever they're hiding, if they're hiding somewhere, and they found a great habitat. They're concentrating, and their movements are dusting. If they're little herbivores, they'll start cleaning the algae, they'll start cleaning it, and we'll end up with a big patch of clean rock, okay? Now that's ideal for the coral larvae to come. And so that's great. Now, another thing is this. Not only are we creating a nice habitat for them to come back to, the coral larvae are looking for a place to settle. And they do it in several ways. One thing, even though the coral larvae the little teeny size of, less than the size of a rice grain, these larvae have no eyes, but they can see color. Okay, they've proven. They can see red and purple. Okay, they've done studies. They love to settle on red and pink, but they don't like to settle on white or black or blue or yellow. They love pinks and reds and purples. Okay, and that turns out that's the same color as the healthy, clean rock, which is crustose coralline algae, or they call it CCA in the reports. The CCA, or the crustose coralline algae, is this pink and purplish algae that covers the dead rocks, right? And that's the ideal settlement surface. So the corals have evolved where they can detect those wavelengths. They can see, and so they're attracted to pink and red, okay? That's something important to know. Because if you're going to make a structure, use red concrete, use pink. So what we use is, I make it out of gray cement, and I take white cement, I mix it up with with red dye, and there's this cheap red dye that's used. It's a water-based dye that mixes well with the concrete, and it's a fabric paint actually. But anyway, and it makes this beautiful pink concrete that I just then put on the outside. It's a little it's not even a plastic, it's like a paint, and it's calcium-based, and we're looking at that as attracting larvae better. But okay, so not only so back to the thing. So the coral larvae are looking for pink surfaces or red surfaces or purple surfaces, and they know that's their coralline algae. So that's going to be around that patch because the corals, the corals are protected fish. The fish have cleaned that algae. So now it's an ideal settlement surface. Now, the second thing the corals are looking for, they're smelling the water, okay? And they found that we didn't know this before, but we suspected it. But now the Japanese have proven it. So when we went to the Motoriki site, back that one that's in the BBC footage, it was in 2004. And the community said, our reefs were killed in the 2000 bleaching. They all turned white and died, and they're not coming back. Okay, look at these dead reefs. And so I went there and said, yeah, these reefs are dead. Why aren't the acropora corals coming back? You have some Porites, but there's no acropora coral. So what we did is, and then the little corals that were coming on the reef edge, there were some acroporas coming that were small. And there was an aquarium industry company, 2 companies were going in, removing those and selling them. So that was inhibiting recovery. So what can we do? So we said, well, we could actually give a replacement in coral farm. So we thought it was going to be aquarium industry that we were focusing on. We didn't realize what we were really doing because nature taught us. So we made 4 nurseries, widely separated on the reef. And so those grew, and the corals were about this big on the next year from little branches. And I looked around there and I said, wow, look at all the little baby corals everywhere, all over the reef. And I said, well, this doesn't need to be restored. It's coming back on its own. But then I'd swim half a kilometer away. Hey, where's all the baby corals? And the other way. So all these 4 nurseries were attracting, because the corals were too small to be making babies there. And babies drift in the water for 4 or 5 days, and they weren't going to be settling right there. So this was actually attracting the larvae. I saw it, and I said, I bet there's a smell coming from these corals. And I didn't know. Now the Japanese have found, a Japanese researcher has found that indeed acropora corals, not the Porites, not the not the brain corals, not the other corals. It's only this one group of corals, the acropora corals, secrete a very smelly compound. It's so smelly. If you actually pick, that's what I do in my workshops. I take a live Porites digitate colony. I take a live acropora colony. I say, smell this. Not much smell. It's nauseating. Okay. And seriously, the difference in the smell is striking. And that smell actually is a pheromone to repel people, to attract coral larvae to their home. Because the more coral larvae that come in, the better those other corals are going to do, because there's defense in numbers and so forth, right?
Right.
So evolutionarily, the corals, and also I believe it hasn't been tested yet, I don't think. I believe they're also attracting the fish larvae, because these acropora corals are the best habitat for fish. So why wouldn't the fish learn,
Right.
oh, this is our home. Hey, let's come. And maybe
Smells like home.
yeah, home sweet home. And the blue colors that these acroporas tend to specialize in blues and purples often, that might also be an attractant to fish. Okay, so nobody knows why they're different colors. And the pink ones too, I think they're maybe attracting babies, because the more fish they have, the better they're going to do. So they say, okay, let's make this chemical evolutionarily. They're making chemical which calls the babies. I believe, calls the baby fish. We've proven the coral part fish. And so here you got your A-frame. It's great fish habitat. Fish are there. And now these corals are growing big enough to the little teeny fish can hide in there, away from the bigger fish that might be hiding under there. And so they have a good habitat, and the reef is cleaner there. The dead rocks are cleaner. You've got all the babies are coming in. They see the pink, and they can smell the corals. And so our nucleation patch grows. I believe maybe, even though this is only released by the acropora corals, I'll betcha that all the species of corals that want to be on that reef have learned that signal. Why should they have to make it if it's already there? Okay, so I would wonder, I don't know, I wonder if Porites also are attracted to that color, the others. So the other genera of corals that don't smell so highly. And I know the fish don't smell like anything that I know of. But yeah, there's fishes, a fishy smell. But I noticed that the bleaching corals also smell a little bit different than the unbleached corals. And so I don't know what's going on there. There's a chemistry going. Maybe they're starting to die or rot or something. So I notice how they smell a lot more fishy. So, but anyway, so there's all this cool stuff going on, and I'm probably not even saying the kinds of things you want me to say.
Yeah, of course you're.
So my point is that we're not restoring the coral cover. We're restoring the natural processes that lead to coral cover.
Yeah.
Okay. And that is a whole paradigm shift that needs to happen in people's minds. Now, if what killed the corals in the first place has not been dealt with, you're in big trouble, because you're going to end up crying when all that amazing work and they're so beautiful. And it's like, look, I'll die. Okay. Yeah. And then that really hurts the soul, the human soul. But also those poor little fish, they don't like it anymore. They don't have a home. So you've given them this home that now all those fish are gonna be impacted, and all the little things that live in there, crabs and shrimp and everything. So we have an obligation to Mother Nature to not be arrogant and think that we are going to solve the problem. We need to recognize that she has been solving this problem for millions of years. The problem of mass problem, death and decline. So she can fix herself better than we can, and she'll do it in a natural way. But we have to now. Okay, this is the key thing. In the past, Mother Nature had thousands of years to deal with change, and now we have a very short time where Mother Nature is being forced to undergo changes that took thousands of years in the past. Yeah. And that's just not fair, because she doesn't have the ability to do that. We're facing the extinction of so many species that she has nurtured for millions of years, 30 million years for most of these species, 20 million years, like that. And now we're facing the extinctions of those in the coming decades. And if we don't get humble and say, oh, if we're going to save Mother Nature, we're going to have to fight this battle on her terms. We're going to have to figure out how can we help her instead of treating her like, we are, the savior, like, no, we have to be humble and say, okay, how can we help you, Mom? Okay, how can we help you? You nurtured not only them, but all these island societies. You've been nurturing us all, giving us free food all these years. We've been taking you for granted. Now, what can we do? Okay, and so this nucleation patch idea, using corals to attract their babies, using fish, and that means no fishing areas have to be established. The communities have to say, yeah, we see it happening, and getting these back. Now, we have reefs in the Pacific that are at every stage of decline. From Kiribati, where it bleached so severely that most of the corals just died, okay? Where even porites died in many reefs, most of the porites, okay? They're coming back now. Their National Geographic just did a special. Oh, very encouraging. The reefs are back in the Southern Line Islands. Sorry, guys. Something has happened there. People are celebrating an alternative steady state condition that's dominated by one species of coral. While in the past, there were dozens of species of corals, and now there's one. Okay, that's nothing to celebrate because that one species now is occupying all the space. And so the other species can't come back. Well, there's no breeding population of them anyway, okay, nearby. So this is a big problem because there haven't been enough people that are autistic or dyslexic or whatever, or ADHD involved in the field. And all the research labs are in Australia, Hawaii, the Caribbean, Florida, whatever. And there really are no research labs. Well, there's one in Moorea, and they have some good data. They have shown that the reefs of Moorea were dominated by acropora corals, these tabulates and digitates, all this diversity of coral dominated on Moorea. They've proven that with their data. And they've shown how that now is dominated by these cauliflower corals, the Poslepora, the pink ones, right? They're pink or brown, and they're just bumpy, okay? And if you look at the reef pictures, very different. And it forms this monoculture of Poslepora on the reef, which still has some habitat for little fish, but not as good, okay? And so that's the steady state now. And the acropora corals, there are a few hiding in farmer fish territories near the shore, okay? But they've died out on the main reefs, okay? And we know that when the mass bleaching continues, that what's giving away to this porites, there's this one particular species, Porites rus and Montipora, the one that's in the Southern Line Islands, which is like a little skinny plate, very thin plates. And they really, I call them monster corals, because if they're on the reef, they can overgrow other corals. They just sheet them over, So if this coffee cup's a coral, they'll just sheet over the coral, and then the coral gets smothered. So the only good thing about the Line Islands is the one species that dominates, it's called Montipora. It is a plating form, and so the plates actually, they're fighting each other, and they come over very close, so it provides a little gap where little fish can hide. So they're really lucky because they have a lot of little fish living in those corals. So you have these clouds of yellowfish and plankton-feeding fish, which that provides a food chain for the bigger fish. So while the corals are very low diversity, one species dominates, the fish population is more diverse and more abundant than say in Tarawa, where Porites rus, which is kind of a bumpy coral with no space in their branches at all. The branches are actually touching, and there's just no place for anything to hide. And in Tarawa, the fish are not there much because they can't find a place to hide. So you got one species dominating. And they've celebrated, the reefs of Tarawa are back now. They're recovered. Look, the coral cover is already 60%. It's all one species. Okay, so we should stop celebrating this. And that's why are we celebrating? Because we don't understand. The main monitoring system for the health of coral reefs in the world is the Global Coral Reef Monitoring Network, the GCRMN. Okay, Global Coral Reef Monitoring Network. Google it. Okay, they deal with percent coral cover. So they'll lay a transect out and they'll count cover versus rock. So it's either coral, live coral, dead coral. Okay, and that's what they do. Okay, Now, that is the equivalent of looking at the rainforest and say, we're going to see barren soil or plants. That's it.
Right.
No distinguishing between grass, bushes, shrubs, or trees. So in the Global Coral Reef Monitoring Network, there's no distinction between coral growth form. So a round parietes is the same as a branching coral, same as a tabulate coral, same as a flat plating coral. So what's not being shown is that the first species to go are the acropora corals, the tabulate, the digitate, and the staghorn corals. These beautiful branching corals that are the best fish habitat are the first to go. And once the fish are gone, then the whole reef system changes, okay? And it's not as good for the communities either because their food is dependent on those corals. So what we have seen in the Kiribati is that you get an alternative steady state. So you have the die-off. You have this beautiful acropora thing, and in 1998, it died in a bleaching. And what came back was Pocillopora dominated, Pocillopora colonies, these cauliflower colonies, and they had huge ones. Biggest I've ever seen are dead now, but the colonies are still there on Christmas Island. So you have an alternative state, which is not so bad, but the acroporas, many species became extinct, and they don't come back again because it's an isolated atoll, nothing up current, not any good breeding populations up current. Or if you have acropora, like what I found, it's one colony's here. Way over there is another colony, if at all. So you'll end up with one or two genotypes that are so far apart, there's no spawning, there's no potential, there's no coral larvae of that species up current. And unless you intervene to help your mama and bring that coral and that coral and that coral all in the nursery, grow them up and then plant a patch, you won't get reproduction, and therefore you will have ecological extinction plus biological extinction as soon as those die, okay? And so we have a window of opportunity to resurrect these ecologically extinct species. There's still enough genotypes of some of them. Mm-hmm. But on Christmas Island, Kiribati, the tabulate corals that used to dominate the island, that are the whole beach is full of these plates. I can't find any. Okay, we've looked for a couple of years and we can't find a single colony. I hear there's one, okay, that we haven't found yet. I hear there's one that survived near the satellite station on the outer reef. But unless we find a second one or a third one, we won't be able to reestablish the reproduction. And so, and if we establish reproduction, we know it's reproducing, we know they're thriving. And then we also have to do multiple patches of it because what if that one dies? And we don't see where the larvae go, but we can just trust, okay, mama, here we got your babies back again. You have to make sure they find the right place. Okay, so we create no fishing areas to help that process along, or we let the fishermen know, if you see these kind of corals, let us know, and then we can start recording the recruitment. But there's really no money for it, and we're just playing around because we're learning. It's okay, we're learning. So we're ready now, though, with a strategy, what I'm calling reefs of hope, where we can actually, if a dead reef is there, we can plant our corals, our reproductive colonies that will start reproducing on the second year, get the fish in there, get them clean. If there are any larvae there, they'll come in, like let's say the massive corals. Why aren't you working with these other species? Well, we don't have to because they are not the ones on the front line of collapse. Okay, so every coral that's holding its own, we're leaving them alone now, knowing they're still spawning probably, and they're going to be the first ones probably to come in on those clean spots that are being created. So we know that we're looking out for the wider biodiversity of the reef system by focusing on the ones that are on the leading edge now. Now, things can change. Like in the Caribbean now, ones like the star corals or the Montastria corals that we kind of left them alone because they were doing their own. They were doing great. But now that rapid tissue loss, horrible thing, is coming and killing most of them. So now they're going to be critically endangered. So more work's going to need to be done on those. So you basically analyze it and say, okay, what's first? That's your first priority. And then, okay, that should be second. That should be third. And so when I went to the Caribbean in 1993, dragged my kids over there, it was a great situation. And I was working already on the staghorn corals, which was the ones that needed to be worked on in the Caribbean. And because that was the one that used to dominate and now was very rare. And so we need to look at how do we be strategic? How do we do what needs to be done most prevalently? And so right now in the Caribbean, there's no program that I know of to collect the genotypes for gene banking. Maybe there is. Gene banking of all the rare corals need to be rescued and kept alive in a flowing water system, or on a better if it's on the reef. But right now there's collections in Florida of all these species that have died out from this rapid disease thing that's going on. And it's all the problems always in Miami. So this started in Miami, just like the lionfish. And so the people say, well, is it the dredging project that dug up some germs? It's probably ballast water from a ship. So what I want them to do is this: with the rapid tissue loss disease in the Caribbean, I want them to actually have an enclosed, secure facility. There's all kinds of Pacific corals you can get on the aquarium industry. They have open industry there. There's actually farms and greenhouses in growing Pacific corals in Florida. You can actually get some of those corals, and I'd like for them to test all the same susceptible types of corals. I would like people to test them against that disease and see if the Pacific corals are resilient or not. If they're just as susceptible, then I'm saying that's not a Pacific disease. But what if it's a Pacific disease that's been in the Caribbean for a million years? Okay, been in the Pacific for a million years, and now it's new in the Caribbean. What if? Now, if it is a Pacific disease, they've proven it, then it came in through the aquarium industry. That's the solution. Or perhaps through ballast water. But that lionfish problem, that came in from the aquarium industry. I knew it was going to happen. I wrote to Coral List way before the lionfish were there. I said, this aquarium industry is a real serious threat because you're bringing in species that, if introduced to the Caribbean, could cause massive change to the ecosystem. And we know there's already tubastria corals there. We know that there's like a couple dozen species of Pacific fish that are now living around Florida. Because when the hurricanes come and you have an aquarium and it starts dying and the ocean's right there, you just go throw your Pacific species in so they won't die, and then not thinking about the consequences. So those lionfish, somebody said, "Oh, we're going to Europe for the summer, and how can we collect this?" "Oh yeah, we're rich. We'll get new ones." And they just throw their lionfish right in the ocean, so they wouldn't die. And now they got lionfish hobbling away. Seriously. So anyway, so I'm just wandering around here. So
Reefs of Hope is the organization that you've created. Yep.
Okay, no, Reefs of Hope is not an organization. Okay, Reefs of Hope is my gift to the world. Okay. Corals for Conservation is our organization.
Corals for Conservation is the organization.
Yeah, and so the paper I just wrote, I'm calling the strategies, these multiple strategies.
The strategies is Reefs of Hope.
Yeah, Reefs of Hope. There's one strategy already existing.
Yep.
And that strategy is called the 50 Reefs Initiative.
Yep.
So this group of scientists, these people have decided that, look, it's like a triage. Like if the reefs are going to collapse, why don't we look at the ones that are the most likely of surviving and focus all the attention on the ones that have most likely of surviving, because maybe we can keep them alive. Okay, and so they're basically abandoning Kiribati, that's been already dead. It's abandoned. You cannot get Global Fund for Coral Reefs money there, because Global Fund for Coral Reefs has adopted the 50 Reefs Initiative. So in my paper, I look at the 50 Reefs Initiative and say, okay, guys, you're retreating now from the front line.
Yeah.
This strategy basically abandons the front line, and you go run and hide in your bunkers, okay? And you go to where your stronghold is and hide in your castle, saying that we are going to survive and keep this alive, okay? But if you're going to learn lessons, you're going to learn them on the forefront. In Ukraine, if they had abandoned the front line, Russia would own all of Ukraine right now.
Right.
So it's a matter of a war going on against climate change. And I know a lot of people don't like to talk about war, and it's putting it in military kind of terms. It offends people. But seriously, we are under attack.
Yeah.
And how can we defeat the enemy, which is climate change, unless we have strategies? And the only strategy that's adopted is go run and hide. Okay, that is not going to work. Yeah. So in my scientific paper, I show a little respect to, because it's at least it's something, at least they're coming up with some idea. Okay, and yeah, we do need to look at which reefs are, kind of rank them. But I question the way they were ranking them. I said, I didn't question the fact that we should maybe focus more on ones on hope spots. But look, they took cyclones as being negative, which was absolutely wrong as far as Mother Nature is concerned. Yeah, cyclones can have a negative impact right where they hit and obliterate the reef, but that is not its big impact. Its big impact goes thousands of miles on both sides, and this skirt is a skirt of protection. It's like you're stomping it right under your feet and you're thinking it's negative, but what it's doing, it's cooling off the ocean. So every time Noah gives these predictions, I've seen it so many times, multiple times, over and over again. Noah gives this prediction that Fiji's going to have a mass bleaching. Fiji's going to have a mass bleaching. And then most of the time, because the water's getting hotter and hotter and hotter, the bleaching's starting. Oh, because of hot water, that's the power that generates cyclones. So a cyclone will come and take all that heat. Mostly people don't understand that a cyclone is Mother Nature, Mother Earth's way of taking excessive heat from the surface of the Earth and exporting it to outer space. So cyclones they're generated by the excess of heat through evaporation. It goes into the air, it turns into wind, and and you form this big high pressure center in the middle, which channels all that heat straight up to right at the stratosphere, and it gets to the stratosphere where it then diffuses and gets out of this Earth. Okay, so it cools off the ocean amazingly, incredibly. So we just had 2 cyclones. Oh, they smashed Vanuatu. It's really bad what happened. Please help Vanuatu. But on the other hand, the western parts of Fiji were facing a mass coral death, completely backed off, no bleaching now. The bleaching that was in January all recovered already. Okay, and so it's our summertime. It is, it just is March, March is your, when is it? March is your, our March is getting into our fall. So it's your September, right?
Our spring.
Yeah, so it's starting to cool off. So, and so that saved us. And it not just saved us, it saved so many of the reefs. And it was just too late in the Lau group, and that's further away from the influence. I don't think it impacted Tonga. It didn't help Tonga very much either. But anyway, it cooled off our ocean at least 1 or 2 degrees. And so the ocean was 30 degrees. It went to 29 degrees, like overnight. So, but anyway, now it's back up to 30 in a few places, but we think it's late enough. We're hoping it'll be okay. So the 50 Reefs Initiative had mislabeled cyclones as negative, and I think they are negative in places like where they get multiple strikes, but overall it's a very, very positive thing. So it depends upon where you are. Now, the interesting thing is that one place in the world that doesn't get any cyclones at all is on the equator, because the Coriolis effect pulls it this way in one side and this way on the other, and that cancels itself out on the equator. So you can't have a cyclone form on the equator. And this, I believe, is why Kiribati reefs have been the most impacted of any on the Earth. And why Papua New Guinea right now is in big trouble, because Papua New Guinea also cannot form cyclones. So this whole thing of on the equator, it would be nice if you did have some cyclone influence. So right there, you have the most impacted reefs in the world, Kiribati on the equator, where for 5 years in a row, it went bleaching for at least 6 months, at least 6 months of the year, 7 months, 6 months of the year was above the bleaching threshold for corals. And there's very little acropora left, almost none. And then Tuvalu, right below that, reefs are some of the best I've ever seen. They've had the least amount of bleaching of anywhere in the Pacific. And it looks like they get the cooling effect of cyclones without any direct impacts. So they are beautiful corals. And so we're looking at patterns now. And the further you go towards the east, the less biodiverse reefs are, but also the greater the impact of the bleaching is. And now you have alternative conditions. So back to this. So the corals start out acropora-dominated reefs that grow fast, best fish habitat, best for people, best for intercepting waves. Then the second stage is Polypora-dominated reefs, which we have now forming. And then the last one is Porites-dominated reefs. And those provide less fish habitat. They're very strong. And they have tissues that go way down into the coral. So the acroporas and Polyporas have tissues only on the outside, but these corals have very deep tissues so that even that gets bleached, and then you can have it regenerate by sending resources out and so forth. So even corals that are proclaimed dead sometimes resurrect themselves. It's amazing. So on Christmas Island, what I found out that there are some corals of Cropper that we knew were dead, whole dead colonies, completely dead. I came back after 1 or 2 years, and you see a little colony of Cropper. You say, oh, look at this. And you realize, oh, that's on an old skeleton. And you see, that's a green one. There's another green one over here, another green one over here. And then here's another one with blue. So we found there's a resurrection going on some of the dead corals, have scraps of tissue way down inside that it looks dead to everybody, but they've somehow maintained little bits of tissue that when given enough time, they grow into little colonies. And now those colonies are probably quite big. I haven't been back since COVID. And so there are species that we proclaimed extinct locally that are coming back, and that's really encouraging. And so like I said, Mother Earth has been around for a long time. Corals have been around for a long time, and they have mechanisms that we're only beginning to understand. They have another thing where the polyps of the coral under stress can actually lift themselves off, pull up, become a larvae again, and swim away and hide down into the cracks of the reef, okay, in the dark places. Wait for the heat to stop, then swim up, then come and plant themselves again. So they can become a new baby, the polyps themselves. That's asexual. It's called polyp bailout, which is kind of cool. So I think that's happening. I think that's what happened in Kiribati, because the first corals we saw were little guys, and there's no upcurrent source of larvae. And the same corals that were dying out, there were some babies there. That, or we thought maybe they were mesophotic way down on the twilight zone, that there might be some of the corals still alive. But it looks like those corals bleached too, so because the hot water went way down. So, but we're not sure. So there's some natural resilience that's great, but if they're coming into an environment that's now dominated by a different species, then they won't have a place to settle down. So that's called the alternative steady state conditions. So I believe corals are going from a highly diverse situation, and then the second stage is lower diverse, but still not so bad. And then the third one is very, very resilient, but not as good habitat and lower diversity. Now, the Global Coral Reef Monitoring Network is not going to be able to detect those phase shifts. And so what I'm telling people, we have to redo this. We have to include the genera. The main genera of corals need to be included in there. And we can group them according to, that whole phase. So Acropora dominated, Poecilopora dominated, Porites dominated, or Montipora dominated. And once we start looking at the world that way, we can go and say, wow. And so the National Geographic guy, they did that study in Bruno, I think his name is, in Southern Line Islands, and they're proclaiming all a healed reef because it's so beautiful. It's full of these cabbage-looking corals, one species full of little fish, and the bigger fish that are eating on those fish. And that's great. The problem is, where is any coral larvae going to come from, and where are they going to settle down to make more biodiversity over time? And I believe that if we go to the beach on those little islands, we will find the former population will be in the skeletal remains. And so if I go look in the beach, I'm going to find lots of plate corals, table acroporas, tabulated acroporas, staghorn corals, digitate. I'm going to go in that beach, if I went there, and see that's what used to dominate, because that's what formed that island, and then I will know for sure, without any other data, that this is an alternative steady state, even if there's no data there. So, but if we keep this in our mind, we begin to realize, okay, after a mass coral die-off, the most important thing is trying to get the corals that used to be there stabilized. So, here's a bit there, and try to get the reproduction going on. And so we try to rebuild that coral population within our nursery, and then in our patches, our nucleation patches. And then we've basically done everything to help Mother Nature, let her do the process. And if anything survives, maybe it's resilient to whatever killed it all, killed off most of them. So if it's 1 out of 1,000 or 2,000 or 10,000 corals, maybe it is a bleaching resilient coral. Hopefully it is. If it's one of these resurrection corals, maybe it's the same, maybe it's not resilient. And if you focus on those resurrection corals, maybe they will all die next time too.
Right.
Maybe they will, maybe they won't. I don't know.
Right.
But, or maybe we could probably say, this is in the lagoon. Let's move that out to the cooler outer reef. Okay. Mm-hmm. So that, and seriously, where these are regenerating are in this shallow reef flats that get really hot. So our idea is to move them. Now, this is another problem we had on Christmas Island. we grew all these beautiful acropores. We actually flew to another atoll, Fanning Atoll, and we found some of the tabulate corals there. And we brought some back and some other corals that were missing. So now we have all these corals. We planted them out, and the parrotfish gobbled them all up. So we cannot plant corals there without the parrotfish eating. There's beautiful big parrotfish. And a couple species, that's their primary food, is like the giant humphead parrotfish. Bumphead parrotfish, that's what they like to eat, is live coral. And they'll just chomp away at it. So we planted corals on the reef and watched them get eaten within just hours. And so what I'm looking at now is sharks. When I do go back there, we're going to trim those corals, and we're going to look for the pass areas that have the highest population densities of sharks, because that's where you'll have the lowest abundance of parrotfish. Yeah. And so we're going to try to see if we can work with the sharks. Yeah. A little bit scary maybe, but we're going to try to work with the sharks to try to get them to protect the corals from the parrotfish, because that's what's eliminating the ones that are trying to come back in. So if you do find a little coral coming in, you'll find all these bite marks on it. So I have a paper that I published on the corals of Christmas Island, and it shows the damage of the parrotfish in those pictures. But anyway, so we're learning to work with nature. We're learning to, you have to respect her, and also learning to do descriptive science, and not everything shouldn't necessarily be hypothesis testing science. We need to, it can be working hypothesis. We're assuming this because we've seen it, and we're going to working on that until something tells us that it's not very good, or we'll refine that based upon new information.
And when we're talking about the survival of life, the difference between significance and importance really comes through. That really struck me as you were saying that this isn't about what goes in a paper, it's about what lives on the ocean floor and in the land. Yeah.
So this is something also, are we scientists more interested in our professional career?
Yeah.
Or actually making a difference in saving this planet? Because the very system that we've studied and learned about is going to collapse.
Yes.
We are the last coral reef scientists if coral reefs don't exist anymore.
Yeah.
Okay? We're the last ones who can actually see healthy patches, healthy pockets, and see what's the natural balances and record that. But it's not even been described properly. If the farmer fish keeping the lingbia off the reef is not described, like I talked about, if the parrotfish attacking the new recruits of corals and keeping the reef from coming back is not known, that means basic descriptional processes that are happening on the reef haven't occurred. So the time for describing things was during the 1800s and the early 1900s, when they did all these beautiful works on ecology. So this old-time ecologists and evolutionary biologists like Charles Darwin, they did all this descriptive ecology and describing things. That never happened for reefs because it was under the water and they didn't have scuba. And even snorkeling was, you had these little things the Chinese had. So it was not, and it wasn't where people lived. So that basic descriptional ecology that we should be relying on now never really got done very well. And now what we have is all these scientific papers, and they're all scattered in the literature. And as far as what does it all mean? All these dots, and nobody's really connected the dots to see what picture it's really drawing. And that's why we need those of a different mental quality. The ones that are ADHD, the ones that are verging on autism or whatever, like me, that the ones who failed or considered poor scientists need to actually be put in the forefront for a change and say, okay, these people that are able to connect these dots so easily, it's just like, how come nobody else can see this? Those of us who can see that and not be able to communicate that, you have to do it this way. And if we don't go through that way, nobody will believe us.
I mean, it's like you are describing the need to create ecosystems with diversity as they occur in nature. We need to recreate that. It's the same way in our system of thinking. In
academia,
in the academia, you need to have that range. And even the solutions that you're talking about are going to apply differently in each location. So it's not about a mono solution. It's about an approach that listens, observes, finds out what works. And what works here might not work there. What works there this year might not work. It might not work there 10 years because the circumstances. So it's
conditions
learning
change all the time.
But learning to work in concert with nature and learning what it is that made these systems to work in the fast place. It's fascinating work. It's fascinating work.
Yeah. So we always have to be looking for new things, and we cannot assume that what we've learned about our system applies to all systems. Now, I have a problem in that paper. In this is that some of the things that I was assuming applied more widely, another scientist that's here on the Coral Coast has a very different system. And so in the system that I was at, we're doing translocation because we have a very strong thermal gradient. We have the outer barrier reef. We have a double barrier reef there, a middle barrier reef, which is cool. Very rare to have a double barrier reef, but we have a cool water outer reef, a warm water middle reef, and we have these very, very hot fringing reefs right up against the island. So we have a very strong thermal gradient, and it's always, because the trade winds come this way, it's always almost always unidirectional. Okay, so the cool water comes in, and then it heats up as it comes, and you don't have this back flow very much. So even the tide comes in and out through the pass, pretty much. It mostly keeps coming in, and it goes out that way because there's all this space and no pass. This huge lagoon there behind the Asawas. So he has done genetics on the corals, and my hypothesis is that your hot pocket corals will be in the hot pockets, and we got to get them out to cooler water. But he's found that there's that hot pockets on the Coral Coast, because it's only 700 meters wide, and then you got your deep ocean there, that they're so close together that every high tide there's mixing between the hot and the cold, hot and the cold, hot and the cold. So it's very different system as far as thermal tolerance. So you might find so these corals are spawning, you might find extremely tolerant corals because those larvae are going out and in and out and in. You're going to find extremely tolerant coral out on the outer reef. Okay. My assumption was that you wouldn't find much extreme tolerance on the outer reef because this unidirectional flow is going. So yeah, it doesn't apply everywhere. But where you have conditions of unidirectional flow and a strong thermal gradient, what I've said in my paper really applies. And the best approach is to go and collect things from the hot pocket. Gets to 37 degrees centigrade in the summer, even when it's not bleaching sometimes. Collect acropora corals, because that's what we're focusing on, or maybe some pulsar, maybe a little bit, anything that's rare. And we take it and we put it in the outer reef. Why?
And make a nucleation patch there of these new, more resilient.
So we want to bring that resilience. We want those hot adapted corals to train what's out there or what comes in, because now that has the lowest coral population, lowest coral cover, because it's been impacted by all those past bleachings. While the middle reef is amazing. The Nuku reef is amazing, that middle barrier reef, because it gets bleached and then it backs off. It doesn't get extremely hot, so it doesn't get beyond the tolerance of all corals, which the inner reefs can actually get beyond the tolerance of anything. And eventually that's going to get up to 40 degrees centigrade and everything will die. Maybe even the parietes will die. So that is on a trajectory to extinction. That's why we're moving those out. But those corals, when they're out, and we also move, so our main gene banks are on Nuku Reef, what we thought was the cooler part of it, but now La Nina's come and done this for 3 years. What's going on here? So maybe some of that resilience is going out there. I don't know. But then if they can't find the reef because there's no corals on it, well, maybe that wouldn't happen. But so we're still learning. And what you've said is what you learn about one site cannot be applied everywhere, but it fits as part of the puzzle. So the last thing is, so I'm trying to get people to read that Reefs of Hope paper. I want people to really change, all the people doing restoration, all the people doing climate change adaptation on reefs. They need to read that paper. Even if they reject a lot of what I've said, I don't care. But they need to start thinking and changing their mental paradigm, because this is a war. We need generals to arise who will then be developing strategies and plans and battle plans and actually combat the enemy and on the front. We need to establish front lines. And those front lines will be where, if we can get the corals back on Kiribati, we can get the corals back anywhere, right? So we need to establish those front lines And we need to defend the homeland, true. Okay, we need all the strategies. And we need troops. And we can't expect those troops to be generals. We need to have sergeants. We need to have other people that we've trained. And so what we're doing here is we're trying to get our curriculum in coral reef restoration for climate change adaptation. We're trying to get it certified as a government certified course where you can actually get university credit for it. And if we can do that, that means you're certified. You know, the Society for Ecological Restoration, you can actually get certified as a restoration ecologist right now and through the society. And we want to actually have some credentials because anybody can pick it up and start planting corals, and they're going to cause no change.
Right.
And so most of the coral work that's going on is going to be ineffective when the bleaching hits and kills all these things. So we're trying to jumpstart natural processes, natural adaptation, natural recovery. And if people can read that paper, get back to me on any things that they object to. And I probably will already agree with them because I'm already moving on and learning new things. But there's most of it really is pretty well strong, and it has all the citations on it. And we're looking at proof of concept now. And so there's going to be at the next COP meetings, there's going to be a new paradigm, a new push. At the last COP meetings, they approved this, what's called basically something from mangroves. It's called basically a mangrove focused, let's save the mangroves from collapse. Coral reefs, we don't have a unified strategy. And if mangroves gets 4 million, at a COP meeting, and coral reef scientists can't get it together to come up with a unified strategy to save the reefs for coral reefs, we're not going to get anything. Okay, we have to come up with a unified strategy that this is our battle plan. All the generals agree. This is the weapons we need. This are the troops, how to train them. This is the curriculum for them. This is what we have to do. And we're going to have front lines here and front lines there. The homeland has to be protected with this and that. If we can't agree to a unified strategy of some sort, the reefs are going to die. And this is why we have to bump, sparks fly, come up with things that we can agree to. So translocation, nucleation patches, looking at how things are appropriate for some reefs and not others, looking at, what's the goal for Moorea? Should we try to get a cropper back on the reef or not? Is it too late? What's still there? There's not even a list of species that used to dominate that are still at least reproductively intact, or at least, we don't even know. And there's nobody really out here. So how can you win a war if there's nobody here? There's nothing going on. Kiribati has 33 atolls, the most impacted in the world. And there are only 5 of those atolls have ever been checked. I checked 2 of them. 3 others were checked by graduate students or something. And one of them declared, "Oh, we're recovered now in Tarla." So they're like, they're always, and all the headlines is positive things. Make a positive headline. "Oh, recovery," because then you can get your paper published in a popular magazine and, everything is great with climate change. Come on, guys. We are celebrating the degradation of reefs just because it got corals on an alternative state. But this is a stepwise thing happening, and we haven't recognized that problem. So just even from this interview, that, whoa, I never heard of that. Oh, I thought farmer fish were bad. All these kinds of things are coming in that are challenging your mental paradigm. And this is the time for challenging our mental paradigms because it's not working. The present dominant paradigms are not going to save coral reefs. And we have to get there and come up with something. Now, I've come up with Reefs of Hope. Let's pick it apart. Find out what you can support, what you believe works, and tell me. And what doesn't, well, that might work in another place. Or what works for your place of those strategies that you say, I can get behind these. So we need to start really combating the forces of darkness in these reefs. And we cannot unless we become a source of light. And what is light? Unity. It's strategies. It's friendliness, it's open sharing, and not hoarding or not, somebody's going to steal my intellectual property and publish before I do. We have to get over the fear of people using our ideas to publish before we do, because that is holding science back too. And we have to allow people in the graduate programs who are mentally diverse and who can see things differently. The graduate record exams had a verbal, math, and another one, which was like correlative skills. And it was out. And I took those and I did okay on, I did pretty good on verbal. Math, struggling. I had to retake it because that was too low. But this other section they had added, I got every question right, okay? Because I could see
patterns,
things that other people couldn't see. And then they said it was prejudice against women. And so they completely changed that into A's and B's and C's and 1s and 2s and 3s, symbols that I don't deal with. And I perform below average on it now. So it was all visual before, and I got every question, not a single one wrong. And I was in the 100th percentile. I was the only person who I think took that test and got them all right. But now they've changed it. So we need to put that visual one back, because it's these visual skills that also, because we get our numbers and letters all mixed up.
Yeah.
You know, we can't think in those kinds of symbols. And so anyway, maybe there are more autistic boys than girls. I don't know. But we need the nurturing qualities that women have. Yeah. And that's why most of the restoration people that I'm training are girls or women. And so we are dominating in this area by women who are coming forward. Melanesian women and Micronesian women. Indigenous women are coming forward. They want to help save the reefs. So these nurturing qualities that women tend to excel in need to be brought in as well. So there's room for all the diversity to save this reef, because we need each of you. We need all of you.
Fantastic. Well, as we can, I hope we can continue to be friends of and amplifiers of the work you're doing, because it's literally, as you know, I mean, our life on this whole earth, if the reefs go, it cascades.
Right.
And
it's a cascading thing.
It's not just important. It's important. It's existential for these island nations, obviously, but it's actually much bigger existential for all of us. All of us. One
thing that's been missed, I mean, so this is way beyond anything, but one thing that's been missed by the scientists is, okay, you know, mangroves are threatened because of sea level rise, and that's the main threat. It's not temperature. Tropical rainforest, it's deforestation and also drought and so forth, and changing climate patterns. But the coral reefs are the only system that the foundation of the stress is heat. Okay? It's the heat because of the bleaching, because of that photosynthesis process, which is decoupling the dark reaction from the light reaction. So the dark reaction is not happening. So you have the light reaction where the sugar molecule is created in this reaction normally, but you start with water and carbon dioxide. So what the light reaction does, it takes the water molecule and splits it into H's and OH's, these free radicals, which then the dark reaction takes and joins onto the carbon dioxide to make sugar, C6H12O6. So if you have the light reaction still working, but the dark reaction doesn't work because the enzymes are heat sensitive, then you create these free radicals and they have nowhere to go. So in that aqueous environment, they become hydrogen peroxide, H2O2. And that hydrogen peroxide burns the hell out of the coral tissues. And so the coral tissue has no alternative but to move his partner out of the relationship and on the edge. And maybe he'll keep her there on the edge. And maybe in the early morning when it's cooler, she'll produce sugar for him. Oh, thank you, honey. Oh, what was that about yesterday? And then it gets hot again and more hydrogen peroxide. And then they end up divorced. So this is a divorce between this amazing productive system of a host and a symbiont, which together they are so powerful and create all these homes for life and create entire nations. And then the heat decouples it and creates this breakdown. And then the poor host starves to death if he's missing his partner. So it is a horrible thing. Now, so back to my point. We need to realize that this is the only system that's really, heat is the main thing. That and the tundra. The tundra is melting away. So the tundra is going to collapse. And, you know, Father Christmas had to move out of the North Pole because it melted. Okay.
Yeah.
But anyway, but the coral reefs, because they're the very first ecosystem that's diverse, that's going to collapse. It has to be where we make our stand. So if we can prevent coral reefs from collapsing, we can prevent every other system from collapsing. And the main thing is that we have to have the time, even a few more decades, we have to have more time because humanity has to change. We have to change our production systems. We have to change our cancerous materialism has to be turned into a more in tune with nature, organic, happy life where people don't consume more than they produce, and where our consumption, I mean, our very existence causes destruction. And you're in New York, you're not cutting down trees, but you are. You know, you're not destroying the corals, but you're causing bleaching by the carbon. So we need to reinvent things, and we just need more time. I wish we had 100 years or 200 years, but we don't.
Right.
And so I don't know what the universe has in store, but I believe the universe is conspiring with nature, to cause this cancerous materialism to have a few stones thrown into those things. And of course, we're so greedy that we've created a system that's not, it's a house of cards. So this house of cards, we got to have the time to keep things alive, because the house of cards has got to fall. And we know that's going to happen. But if it falls in 100 years, it's too late. So the sooner the better. But in the meantime, we need to keep things alive. And even if the house of cards falls, the climate change is with us now. We've changed the atmosphere. So it's even if humanity disappeared right now, suddenly, boom, we're gone. Mother Nature's still going to have to deal with a hotter world. And so, it's going to take a while before they can absorb that excessive carbon and so forth. So, and so the tools that we're developing now, even if we get our act together, it's going to still be needed to be applied for the next 50 or 100 years. We're still going to need to use these techniques as a society. And so we're focusing on training local communities who are already reestablishing their no fishing areas. And we're just saying, instead of your corals dying every 5 or 6 years, let's make it so your corals stay alive so the fish will have lots of homes. And so this makes sense to the local community. It's not rocket science. It's something they can learn. And they're doing it for their own production of their own fish. And they're doing it in their own traditional no fishing areas that might be rotational, that might be permanent. But if people are the problem, people are the solution.
They have to be.
And so we have to focus on people. We have, and we can't say they're the enemy. They are the best friend of transformation, because people, once they get illumined up here, they have a huge power to change their lives. And so we need to somehow just believe. I believe that what I'm doing is going to have an impact, a positive impact. And I believe that ultimately I'm depending upon the universe to rise up, to do what it can to somehow lower our impact, either through whatever, So
that's another 2 hours of conversation.
But anyway, so thank you very much for inviting me to talk. And I love to talk. So
I've noticed. Well, I think we've just gotten through you introducing yourself. So I thank you so much for.
And if it's going to be really hard for you to edit this, I know. So sorry about that. But if you can come up with something that really gets things to stir, thank you so much. Thank you so much for getting people's attention.